Exercise number 2. Let's do it. So first question, two particles are in SHM on a straight line with amplitudes A and 2A. Oh, so different amplitudes. Okay. And with the same angular frequency. Well, that's nice. It is observed that the first particle is at distance A by 2. Well, you know what? I'm gonna do the same stuff once again. So it's just that the amplitudes are different. Not exactly like. So I'm gonna draw two circles, one with twice the diameter, right? So if this is A, this would be 2A, and well, the phase is, everything is still the same, right? Okay, same angular frequency, nice. It is observed that so that means that the phase difference will still remain constant. It is observed that when the first particle is at distance A by square root 2 from the origin, so A by square root 2, that's more like A sine pi by 4, which can be at which points? Well, this point, this point, this point, or this point, and going towards the mean position. Well, the velocity would be like this, like this, like this, like this. Only in this position and in this position is it going towards the mean position. So that means that these are not correct, and only these are the ones which I should consider. Okay. Other particle is at an extreme position on the other side of the mean position. So it's either this condition or this condition. So other side of the mean position, it should be like this. Okay, cool. Find the phase difference between the two particles. Wait, A by square root from the origin and going towards mean position. Wait, so are their mean positions the same in the first place? It's at extreme position on the other side of the mean position. Wait, what? I don't get it. Well, that doesn't make sense though. So now you need to draw these circles different. Wait, but that's not good. Is an extreme position. Well, all that really matters are the phase, right? So cool. Anything else doesn't matter. So the first one, it's showing this as the phase difference. Other one, well, if it's on this side, it's on the other side, right? So it can be over here or it can be over there. This is so complicated. So why are their mean positions not the origin though? I don't know, it's gonna take the special case where it is the origin to solve this. Fine. So in that case, this is one thing that can be happening, or this is the one thing that can be happening as well. So what's the phase difference? The phase difference is this much, which is, well, this is 45 degrees, so it should be 135 degrees. Right, which is like 3 into pi by 4, so 3 pi by 4. That would be the phase difference. Yeah, that looks correct. Next question. Yeah, definitely. It is correct. A particle is executing SHM of amplitude A about the mean position x equal to 0. Okay. Which of the following cannot be possible phase difference between the positions at x equal to plus a by 2 and minus, just one second, draw this thing. So plus a by 2, that would be 30 degree, I believe, right? So this is half of that. Yeah, it should be 30 degrees. And minus a upon square root 2, so it would be somewhere there. It's gonna be 45 degrees. So which cannot be a possible phase difference? Well, at x equals to, wait a second, it can be this thing and it can also be this thing. Okay, plus 2 and pi, but that you really get it, right? So it can be pi by 6 or 5 pi by 6, and this thing can be minus pi by 4 or what else do we have, or it can be this thing which is I guess pi plus pi by 4. So like pi minus pi by 4, which would be minus 3 pi by 4. Cool. So it's gonna be 4 combinations. Well, that's really bad. In fact, let's just do it in angles, normal angles. Minus 3 pi by 4 is like minus 90, 45, 135 degrees. Minus 45 degrees. 30 degrees. 150 degrees. Cool. So we have to do all 4 combinations. So this is gonna be 75 or 195 degrees or 165 degrees or 285 degrees. By the way, for this thing I'm gonna reduce it, so nah, let it be, don't reduce it, because you will have to do 360 degrees for that, so no, don't do it. So which of these cannot be right? 165 degrees it can be, 135 degrees, well, it's not there. 195 degrees, yeah. 75 degrees, yeah. This cannot be the thing. Speed v of particle moving along a straight line when it is x from a fixed point on the line is given by, okay, all quantities in SI unit then. From a fixed point along the straight line, right? So let's just use that as the origin. So v is 108 minus 9x squared. So 108 at the mean position. Okay, the motion is uniformly accelerated along the, and what's the amplitude though? Maximum displacement is when v squared is like 0, so you just get x squared equal to 108 upon 9, which is 12. So x would be 2 square root 3. Well, yeah. Wait, about x equal, no, not necessary. Wait, what? That doesn't make sense. What even? Huh. Nah, this is weird. Okay, maximum displacement from fixed point is 4 centimeter. No, it's not 4 centimeters. It's all in SI units and stuff. It cannot be like that. The motion is uniformly accelerated along the straight line. No, it's not uniform acceleration, it's linear acceleration. The magnitude of the acceleration at distance 3 centimeter. 3 centimeter. Oh yes, like 3 to 10 pounds minus 2 meters, right? Okay, is 0.27 meter per second. From where do these people even get this? So what should be the thing? 108 is the maximum. It's gonna be half k amplitude square, or amplitude is just this thing. It's like half k. Wait, no. V squared would be k amplitude squared. So k we don't know. Amplitude squared is just 12. Okay. It should be 108. So k is just 9. Omega is 3. Well, okay, let's say x equal to 2 square root 3 sine theta, sorry, sine omega t, so sine 3t, then v would be, it's going to be 108, square root of 108 for sure. Square root of 108 cosine of 3t. Nice. What else do we have? The motion is uniformly, magnitude of acceleration, well, okay, acceleration is going to be 2 square root 3 cubed into sine of 3t, I mean magnitude of that. So at what, at distance of 3 centimeters. Well, why don't we directly use kx for this? We already know what k is. It's going to be 9, so just 9 into 3 upon 100, which is, yeah, it's just 0.27, so that's correct. when the plank is momentarily at rest. Wait, what? Forming SHM along the vertical line with amplitude of 40 centimeters. Fine. The block just loses contact with the plank when the plank is momentarily at rest. So it would be at the extreme position for sure. The period of its oscillation is 2 pi by 5 seconds. Right, so let's just find whatever acceleration should be. Acceleration is a omega squared. We already know what the amplitude is. A omega squared sine of omega t. Right, so this thing will just turn out to be pi by 2 in that case, so it should just be gone in that. So that's when this acceleration is like maximum stuff. It's also, yeah, so that's the acceleration required. That's the required acceleration, which is provided by, wait, well, negative of that, yeah, well, that would be required acceleration. So n by m minus g. Yes, that gives g equal to n upon m. It's like, okay, so n is 0 because it loses contact, so it just becomes a omega squared equals to g. Amplitude we know it's just 0.4. Omega squared we don't know. G we know it's 9.8. Omega squared is 98 upon 4, which is 49 upon 2, I believe. So omega is 7 by square root 2. Yeah, is that correct though? What about I take 98 by? It's getting frustrating. In fact, no, we just take 10 as the value of g in this case. So it just goes over there. Just get omega squared equal to 10 upon 0.4, which is like 100 upon 4, which is 25. So omega is 5. Omega being 5 gives t equals to 2 pi by 5, which is 2 pi upon 5 seconds basically. Yeah, so that would be like, oh, it's already over there. So the period of oscillation is 2 pi by 5 seconds. Nice. The block waits on the plank double its weight when plank is one of the positions of momentary rest. Okay, so you mean the normal force is 2 times. Well, also it's more like this. When this was just resting, it was 0. This over there, then it goes to the mean position. Over here it would be 0. Yeah, so the normal force would be 0, and then it goes like this, where normal force will be 2 times whatever the weight of this guy is. Here the normal force is the weight of this guy at the mean position. Here the normal force is 0. Here the normal force is 2 times the weight of that guy, which means, yeah, that is correct. Okay, the block weighs 1.5 times its weight on the plank halfway down from the mean position. Halfway down, well, yeah, I mean, like, the normal force is in fact that thing, so correct, no big deal. The block weighs its true weight on the plank, then the velocity of plank is maximum. Yes, that's correct. It's gonna be at the mean position, so it's correct. Sure, these two are the positions where velocity is 0, but here it's maximum. Next question. The displacement time graph of a particle executing SHM is shown. Which of the following sequences are true? So velocity is maximum at small t equals to capital T by 2. So this is y is maximum at this point. This is more like a cosine graph actually. So y equals to cosine of, well, the time period. think. So x0 and then it becomes pi by 2. Okay, when it becomes pi by 2 it's gonna be 0. At t by 4 it becomes pi by 2, so pi by 2 upon t by 4 into small t. Cool. So this is just cosine of cancels. No, this is t by 4. So this goes 2 pi upon capital T into small t, obviously. Nice. Okay. Velocity is maximum at small t equal to capital T by 2. Well, what's the velocity? Velocity will be minus sine, okay, minus 2 pi sine, so 2 pi by t actually, sine of 2 pi by t, small t. So is it at t by 2? No, because at capital T by 2 it will be pi, which is 0, so no. The acceleration is maximum. Okay, so acceleration is minus 4 pi squared upon t squared cosine of 2 pi by t capital T upon small t, whatever. Its maximum at t equals to capital T. Well, that would be cosine of 2 pi. Well, I mean its vector quantity is negative, but its magnitude is in fact the maximum. I don't know. The force is 0 at 3t by 4. So at 3 by 4 it's gonna be 1. At that point, what's cosine? Cosine is 0. So yeah, looks correct. I mean, like 3 pi by 2, it's gonna be 0. That's correct. Potential energy equals the oscillation energy, which means the total energy, I guess, at t equals to capital T by 2. Okay, this is so weird. T equals to capital T by 2. What's the position though? Capital T by 2, that cancels. Just get 0 over there, so cosine. Okay, so you mean at the mean position? That doesn't quite look correct. Well, I mean, like, it is actually the correct though. Potential energy is in fact no, kinetic energy is oscillation. Yeah, so this is incorrect. The potential energy of a particle of mass something moving along x-axis is given by this thing, where x is in meters. It can be concluded that why are these questions so okay, whatever. Particle is acted upon a constant force. The speed of the particle is maximum at 2 meters per second. The particle executes simple harmonic motion. The period of oscillation of the particles by 5. Okay. Well, yeah, I mean, it could be sure, but you got two of those things. So what's the force though? Force is so actually is like potential is 5x squared minus 20x. So the force is just gonna be 10x minus 20, which is 10 into x minus 2. So it's like linearly related. So if it's h distance away from the point x equals to 2, then the force will be 10h. Actually, it should be negative of this thing. So just negative 10h, which makes sense, right? It's gonna be SHM. It's a 0.1 kg particle, so acceleration is just negative 100h. Okay. So particle is okay. Speed of particle is maximum at x equals to 2 meters. Yes, that's correct. What happens at x equals to 0? Well, at x equals to 0. Okay, fine. That doesn't even matter because so x equals to 0 and x equals to 4. Can we also graph this like, okay, wait a second. It's like 0 and 4. Potential energy curve is something like this. The minimum potential energy is in fact at 2. So yeah, it seems legit. The particle executes simple harmonic motion. Yes, it does. cm looks correct. Oops, wait a second. The period of oscillation of the particle is pi by 5 seconds. Well, what's omega? Omega is just 10, so 2 pi by 10. Well, yeah, it is pi by 5. The particle is acted upon by a constant. No, it's not. A particle is executing SHM with amplitude A, time period capital T, maximum acceleration A naught, and maximum velocity V naught. Okay, it starts from mean position at t equals to 0 and time t. It has the displacement a by 2. Okay, whole acceleration a and velocity v. Then I cannot believe they are still doing this. Okay, fine, we will find everything in that case. We need to find the acceleration and wait, what? V equals to alright, so we can actually do this. It has displacement a by 2, so that sine thing is 1 by 2, which means your angle, well, that must have been 30 degrees, right? So 30 upon 2 pi is like pi by 6 upon 2 pi, which is 1 by 12, so it's capital T upon 12. What's the acceleration? Yeah, it's definitely half the acceleration of what it would be at that point. Okay, what's the velocity? No, it's not half. It's square root of 3 by 2 times that, so no. The amplitude of a particle executing SHM about O is 10 centimeters. Then, ouch, my neck hurts. When the kinetic energy is 0.64 of its maximum kinetic energy, its displacement is 6 centimeter from O. Okay, 0.64 of its maximum kinetic energy, which means, okay, wait a second, maximum kinetic energy is essentially the total energy, right? So 0.36, so potential energy is 0.36 the total energy, which means it's its length, it will be 0.6 times the maximum length, so it is 0.6 a as the displacement, which means it's 6 centimeter from O. That's correct. When displacement is 5 centimeter from O, its kinetic energy is 0.75 from its of its maximum potential energy. Well, if it's 5 centimeters, why is like fishy though? Okay, so it's gonna be a by 2. Potential energy is 1/4. Kinetic energy is 3/4 the total energy. Well, we have not yet defined the potential energy though. I mean, like, okay, if we do define it to be 0 at the mean position, then yeah, looks correct. 3 by 4 is 0.75. Looks correct though. But I think I should not be choosing this because we still have not defined potential energy. A total energy at any point is equal to maximum kinetic energy. Wait, what? I mean, no, we have not defined the. Okay, that doesn't seem to be making sense. Its velocity is half the maximum velocity when its displacement is half the maximum displacement. What? No. It's gonna be square root of 3 by 2. So, no. I guess only A is correct. B and C, I don't know if they are correct or not. So, I'm gonna put dot over there. Okay, whatever. Next question. The displacement of a particle varies according to the relation x equals to 3 sine of 100t plus 8 cosine squared 50. Yeah. 3 sine 100t plus, it's like 4 into 2 cosine squared is like 4 plus 2, so it's like 150 as well, which is 4 plus 5 sine of 100t plus sine inverse of 3 by 5. Cool. Correct about motion of particle is not a SHM. this is the displacement of the particle, right? So that means x minus 4. Well, I mean it is an SHM, but about the point x equal to 4. So we want the correct statement. The amplitude of SHM of the particle is 5 units. Yes, it is. The amplitude of the resultant SHM is square root of 73. What? No, no, no. How? That doesn't make sense. The maximum displacement of a particle from the origin is 9. Yes, it is. In SHM, acceleration versus displacement from mean position. Okay, graph. Okay, acceleration versus displacement. Yeah, it's just a straight line. It's always a straight line passing through the origin, and slope -1. No, not -1. It's gonna be minus k. It is it's a straight line, not necessarily passing through origin. Acceleration versus displacement. Well, that doesn't make sense. From mean position graph. So yeah, it doesn't make sense. Why would you put slope -1 and stuff? It shouldn't be like minus k. None of these. Not necessarily passing through the origin. Who says so? It must pass through the origin. Okay, a particle moves in the xy plane according to the law x equal to a sine omega t and y equal to a into 1 minus cosine omega t, where a and omega are constants. The particle traces. Okay, let's try it out. Why do I feel it's gonna be something like a parabola? Sorry, an ellipse. An ellipse will be better. Fine. So x upon a equals to sine omega t. Y upon a minus 1 is minus cosine omega t, which means x squared upon a squared plus y minus 1 squared upon a squared is 1. So yeah, it's gonna be an ellipse, a straight line, a circle. Oh, not even, it's not even an ellipse, it's actually a circle, because these a, yeah, it's a circle. Distance proportional to time. Wait, what? That doesn't make sense. Next question. For a particle executing SHM, x equal to displacement from equilibrium position, v equals to velocity at any instant, and a equals to acceleration at any instant. Okay. Then Vx graph is a circle. Vx graph is not necessarily, I mean, like omega, it's an ellipse. Well, yeah, because v is amplitude omega cosine of the angle, acceleration is a omega squared sine of the angle minus of that, but you get it. So it's gonna be an ellipse. A v graph is an ellipse. Sorry, what was it? Vx graph is an, yeah, well, that's correct. This is also correct, in fact. Vx graph is a circle. No. Ax graph is a straight line. Yes. The figure shows a graph between velocity and displacement of a particle performing SHM. Okay, velocity and displacement. Cool. The time period of the particle is 1.57 seconds. Okay, fine. The maximum acceleration will be 40. Oh, so we have to find this. This is x, this is right. I mean, like, that's a nice graphical representation. So this is 2.5, right? Okay. Maximum acceleration and everything. This is so okay. X equal to 2.5. It's gonna be a cosine theta, something like that. Not cosine theta. This time we will be using sine theta. Sine of omega t, and v is 10 cosine of omega t, which means 10 upon 2.5 is just omega, and this thing is really just 100 upon 25, which is 4. So omega is 4. Nice. So now what do we want? The maximum acceleration, well, that would be 16 into the maximum displacement, which is just 2.5. So that will be 8 into 5, I guess it's going to be 40. Yes, that's correct. Centimeter per second. Oh, so it's in centimeter per second. Fine. So we're just going to use the CGS system. The time period of the particle is 1.75 seconds. So it's going to be 2 pi upon omega, which is 2 pi upon 4. So it's going to be pi upon 2. Well, yeah, looks like that. I mean, not exactly, but yeah. The velocity of particle is 2 square root of 21 centimeter per second when it is at distance 1 centimeter from the mean from the mean what am I speaking from the mean position. Well, okay, so it's 1 centimeter from the mean position. Fine, so x is just 1. Yeah, so 1 squared upon amplitude, which is, wait a second, but why is that 10 centimeter per second? Something is wrong. Why is this 2.5 and shown to be bigger? Whatever. So upon a squared, it's like 2.5 squared plus b squared upon b squared equal to 1. Cool, we can just find it out. So b squared upon 10 squared equal to 1 minus, well, 1 upon 25 squared. It's more like, well, 25 is 5 by 2, so it's going to be 2 by 5 squared, so minus 4 upon 25, which is, well, 21 upon 25, 42 upon 5. Okay, 1 centimeter. Something is wrong. 5 by 2. Oh yeah, something is wrong. Sorry. So more like v by 10 equals to square root of 21 upon 5. So v is 2 square root of 21. Yes, that's correct. None of these, well, it's all of these actually. Equation y equals to 2a cosine squared omega t and y equal to, this is the motion of two particles. Okay, let's do it. So the first one is y equal to amplitude into amplitude plus amplitude, cosine of 2 omega t. It's like y minus a equal to a cosine of 2 omega t. Nice, that's SHM. Okay, and equals to a, y equals to 2a sine of omega t plus pi by 6, I believe. Yes, that's correct. Cool. Oh, sorry, not pi by 6, pi by 3. Fine. Ratio of maximum speeds, ratio of maximum acceleration, ratio of maximum. Only one of these is in SHM? No, both of them are in SHM. Ratio of maximum speeds. Okay. Fine. So just find the v maximum. It's like v would be 2 omega a minus actually sine of 2 omega t, right? So it's maximum when this thing is 1, so this one's like, and this is actually positive. Okay, and from here we get v equal to this goes over there, it's just 2a omega. Once again, everything is same stuff, so like just 2a omega. So yeah, it's 1:1. Weird but true. Okay, looks correct, I guess. Okay, next what? Only one of these in SHM? No. Ratio of maximum accelerations is 1:4. I need to find the acceleration as well. So acceleration will be for the first guy. For the first guy, it will be 4 omega squared a times cosine of 2 omega t, stuff like that, so just gone. And over here, just get this thing squared, so just 2a omega squared. So the ratio is 2:1. Yes. Sorry. No. 1:4? Well, no. No, 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 no. That's not what I'm getting. Did I make some mistake? Well, 2 times of... Okay. 2 cosine squared of a is only 1 plus cosine of 2 omega t. Differentiating, you do get that thing, so no problem, right? Well, so yeah, this is correct. Next question. A particle starts from a point P at a distance of a/2 from the mean position O and travels towards left as shown in the figure. Okay, so where is P though? At distance a/2, so this point is P. It starts from here and travels towards left. So okay, fine, that's kind of weird. If the time period of SHM executed about O is t and amplitude a, then the equation of motion of the particle is okay, just draw this thing. So right now it is at a/2 in this direction, so it should be somewhere over here. This angle is 30 degrees. Okay, but it could also be over here. Okay, and it is moving towards the let's should be going like that, right? Because it, yes, but here it's gonna be like this. Yes, as your angle increases, you go forward like, okay, cool, which means it's gonna be this thing that we will use. Okay, x equals to a sine, what's this angle? 150 degrees, which is 5 pi by 6. So a sine of 5 pi by 6 plus omega t. Yeah, and what's omega? 2 pi by capital T, small t. Looks correct. It's gonna be 5 pi by 6 for sure. This basically gives us the defining feature of this thing. Next question. A mass of 2 kg, 0.2 kg is attached to the lower end of a massless spring of force constant 200 Newton per meter, the upper end of which is fixed to a rigid support. Which of the following statements are true? In equilibrium, the spring will be stretched by 1 centimeter. So this is a mass of 0.2 kg. Spring constant is 200 Newton per meter. 1 centimeter if the mass is raised. Okay, first of all, for the equilibrium condition, what do we have? We have 200 x equal to 0.2 into, well, what's g first of all? I guess we just have to use 10 in this case. So this is gonna be 200x equal to 2, so it cancels, just get 1. So x equal to, yeah, it's 1 centimeter, almost 1 centimeter. If the spring is raised, if the mass is raised till the spring is in unstretched state and then released, okay, it will go down by 2 centimeter before moving upwards. Go down by, so starting from the relaxed state, yes, it will. The frequency of oscillation will be nearly 5 hertz. Okay, let's do it. What's the force? The force is kx. Okay, I mean, what even is this? We already know what this k thing is, just k by m, right? So k is 200 upon 0.2, which is 1 upon 5, so it should be 1000. Wow. Okay, so 1000 is omega squared. Okay, omega should be 10 square root 10, which means, well, this is in radians per second, we want in hertz, so this is like 10 square root 10 upon 2 pi cycles per second. So this should be 5 square root 10 upon, oops, not 2, so yeah, upon pi. It's nearly 5 hertz. Well, square root of 10 upon pi, yes, it's nearly 5. Yes, 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 because this thing turns out to be very near to 1. Square root of 10 is almost like 3.14. If the system is taken to be to the moon, the frequency of oscillation will be the same as on earth. Yes, yes, it will be the same, just the equilibrium position will be different. The angular frequency of a spring block system is omega naught. This system is suspended from the ceiling of an elevator moving downward with constant speed v naught. Wait, what? Oh, constant speed? Well, no, not a big deal. The block is at rest related to the elevator. Lift is, oh, it suddenly stopped. Shit. Assuming the downward position. What? It's a positive direction. Okay, choose the wrong statement. So just stopped it, but it is still moving with v naught. Okay, cool. Initially it will not pull, so it's actually the mean condition that you just gave us. So it's like this. Once it stopped at t equals to 0, it still has this velocity v naught going on. Initially it was angular frequencies omega naught. Well, still it should be omega naught as well. Assuming the downwards as positive direction, choose the wrong statement. The amplitude of the block is v naught upon omega naught. Well, v naught is the maximum velocity. Okay, so we can say v naught squared equals to k, which is just omega naught squared, yeah, times x squared. Well, x, I should say amplitude squared. So yeah, v naught upon omega naught is in fact the amplitude, but we have to choose a wrong statement. The initial phase of the block is pi, so this is considered, the downward is considered as the positive direction, right? Right now x is increasing. The cosine thing, well, it should be positive. So no, it's not pi, which means this is actually the wrong statement. The equation of the motion for the particle is v naught upon omega naught sine omega naught t. So we know what amplitude is, v naught upon omega naught sine omega naught t. Yes, that looks correct. The maximum speed of the block is v naught. Yeah, that is also correct. Yes, this is correct. The block is at rest related to the elevator. Just wait a second. If it is moving at the constant velocity, well, it's not accelerating. That means that this and this are equal. Yeah, it is perfect, I guess. It's definitely at the equilibrium position where the force would be 0 on this. Cool. Next condition. A cylindrical block of density rho is partially immersed in a liquid of density 3 rho. The plane surface of the block remains parallel to the surface of the liquid. The height of the block is 60 cm. The block performs SHM when displaced from mean position. Okay, we want the maximum amplitude, the time period. Okay, cool. So let's do it. So what do we have? If we move by x, the pressure on this, the axis pressure, the extra pressure, I don't know, whatever. So it's just going to be density of water times the displacement which we moved, okay, times g, rho hg, yep, times the area. That's the force upon the mass of this guy, which is the density of a solid, times its length times the area. So this cancels. Okay, cool. This would be the acceleration, and actually it should be negative. So it's gonna be negative rho w upon rho s L into x. Oh, actually it's g as well. So rho w is 3 and rho s is, so yeah, this ratio is just 3, so minus 3 g upon L. What's that ratio? G is 9.8. Height of the block is 60 centimeters, so it should be 0.6 into x, which is minus 98 upon 2, so like minus 49 x. Okay, so omega square is 49, omega is 7, the time period is 25/7 seconds. Yes, that's correct. Yep, I did put everything in SI units. The maximum amplitude is 20 centimeters. Wait, how? Height of the block is 60 centimeters. Okay, well, we didn't even, why would we know what maximum amplitude is? Oh, so maximum amplitude, well, okay. So first of all, we need to find where the equilibrium position is. So the length of the solid, which is 60 centimeters, 0.6, times the density of the solid, which is like 3 rho, equals to the density of the liquid, which is rho, times the length immersed. So the length immersed is just 1.8 meters. Okay, cool. So wait a second, so it's immersed, it's getting weird. Length immersed is 1.8. Well, yeah. Oh, sorry. This should be rho and this should be 3 rho. Oops. So liquid is more dense, so it should be 0.2 in that case. So it's gonna be 0.2 meters, which is like 20 centimeters. So it's 20 centimeter deep. So yeah, if I just say I pull it till here, it will do SHM. Say I pull it over till here, it will still do SHM. But if I pull it out of the water, that will be a problem, because yeah, now it's not SHM, it's more like a set wise definition depending on where it's out of water or inside. So I guess its maximum amplitude is 40. I mean, it could be that, okay, that thing is not called SHM, it's a complicated thing, whatever that thing is. Next question. A system is oscillating with undamped simple harmonic motion, then average total energy per cycle of motion is the maximum energy. Average total energy, okay. I mean, how it doesn't even change. Total energy is constant, right? Per cycle of motion is its maximum kinetic energy. But yeah, it is the average total energy per cycle of motion. What even is this average total energy thing? What is this? Isn't the total energy a constant? Are we defining it some other way? So it's undamped, so it doesn't change. But now, according to what I know, it's a constant. Next, root mean square velocity is 1 by square root 2 times its maximum velocity. Okay, now that's a condition which we need to figure out. So the root mean squared, right? It's gonna be summation of v1 squared plus v2 squared. So say we partition it into equal lengths of time, say dt time. So then this will be, how many of these do we even have? So for a particular time t, you will have t upon dt, that small t upon dt, these many of these will be there. It's going to be v1 squared, v2 squared, so on. Yeah, so we can write this as square root of So pulling that dt over there, v1 squared dt plus v2 squared dt and so on. So say this thing is like n, so this would be n, so it's gonna be eventually till vn squared dt. And guess what, limit as n approaches infinity, this thing is in fact the definition of the integration. So this is actually square root of the integration of v squared dt, going from, well, guess what, from t equals to 0 to, well, is this correct though, v squared dt, just summing that up. Well, we need to find this in terms of v somehow. Well, yeah, so we want to be summing this from where to where. Once again, since we want one complete oscillation, just say 0 to 2 pi. Okay, so this should be square root of the integration from 0 to 2 pi v squared, that's gonna be a squared omega squared cosine squared of omega t. Okay, cool. dt, I believe. Okay, is that correct? Yeah, I mean, it looks correct. Very fine. So this should just be half the integration of, actually half a squared omega squared integration of, actually square root of that as well. So square root of a squared omega squared upon 2, and this is going to be 2 cosine squared omega t, which we can write as 1 plus cosine of 2 omega t. Yep, dt is going from 0 to 2 pi. Well, this thing, if we integrate it, we're gonna get sine of omega t times some constant. So 2 pi and 0, well, both make that thing 0. So yeah, just neglect this. So it's gonna be 2 pi over there. Yeah, so it just becomes pi a squared omega squared square root of that. Well, I was not expecting this thing. Yeah, well, how did this turn out to be the answer? Oh, sorry, it's not 2 pi. Right, it's not 2 pi. It's integrating omega t dt from, oh boy, from where to where? From 0 to capital T. Okay, cool. Yep, that looks correct. It's like dt. Yeah, it's got to be like this. Capital T. So it's gonna be sine of 2 omega capital T, and capital omega is just like 2 pi upon capital T. So I guess it's still the same stuff. So this does cancel, so you just get capital T a squared omega squared upon 2. Yeah. So this should be square root of a squared omega squared capital T upon square root 2. Nice. Well, is this 1 plus square 2 times the maximum velocity? What's the maximum velocity though? The maximum velocity is a omega. Something is not correct. Yep, definitely something is not correct. Why is this t for some reason? Why this should be 2 pi over there? What's going wrong? Did we even get something correct? How many of these do we need? Well, we need n of these. N is just given by, oh shit, that's where it went wrong. We did say it was like t upon dt, right? So that would be n, so it should be t over there. Yeah, in this case, instead of t we will have capital T over there. Well, that makes sense. So this capital T is not supposed to be there. It's like, yeah, so that definitely makes a lot of sense. So a omega, cool. Mean velocity is 1 by 2 of maximum velocity. Mean velocity, well, that would be like the integral of a omega cosine omega t from 0 to capital T dt upon capital T. Yep, well, the small people thing. So this will just be a omega, what is like sine, a sine of omega t going from 0 to capital T upon T. Well, did we do something wrong? Nope, it looks correct. Just putting this over there, you get omega t, what is like a sine of 2 pi by capital T times, well, that would be 0. So mean velocity is just 0. I mean, yeah, mean velocity is 0, mean speed is not 0. So yeah, this is not correct, but it could be if they asked mean speed. Well, I mean, not necessarily, because it's like decreasing very non-linearly, it's cosine and stuff, so no. Next question. A particle of mass m performs SHM along a straight line with frequency f and amplitude a. The average kinetic energy of the particle is 0. The average kinetic energy of the particle is 0. No, it's not. The first one is wrong. The average potential energy is what's this, m squared f. Hey, we did figure out what this thing is, right? So 1 by square root 2 times a omega, that was the average, the root mean velocity, right? So the average kinetic energy, well, that's just half m into root mean velocity squared. Yeah, that would be correct. Yes, so it's just half m in the v squared, so like 1 upon 2 a squared omega squared. In this case, omega is like f, so okay. So, but where is that pi and stuff? Well, it's not there. It's potential energy. In that case, it must not be like that, right? Or is it? It's like m by 4 something. Okay, that doesn't seem to make sense. Why would this be pi squared? And do I have to integrate once again? The average potential energy is just half kx squared, right? So it's gonna be half mkx squared. Okay, mkx squared dx. Dx? No, dt upon capital T. Wait, did I just... So averaged over time or displacement? Oh no. Because both will give different answers. So that kind of doesn't make sense. You need to be defining this. I guess by average they do mean with respect to time, so it would be like 0 to capital T. And this thing is just like sine squared and stuff, so... Well, yeah, just... We're still gonna get 1 minus cosine, so everything still turns out to be pretty much the same stuff. So it's gonna be 1 by 4. And you're gonna have 1, and the other thing is just gonna get neglected because that's 0. So it's integrating this thing from 0 to capital T. That would be 1 by 4 mk. Yeah. X squared. Oh, for x squared you also need the amplitude squared though, so mk into a squared. Okay, that looks correct. It's gonna be 1 by 4 m. Yep, it's not this thing. The velocity, the frequency of oscillation of kinetic energy is 2f. What? Frequency of oscillation of kinetic energy, okay, is 2f. Yeah. I mean, okay, yeah. So it's periodic. The curve for the kinetic energy is periodic, Well, for velocity it would be like this, right? For this guy it's more or less like this. Yeah, something like that. So okay, fine. 1 plus cosine of 2 omega t. So yeah, so omega dash is 2 omega. Its frequency is in fact 2 times. Velocity function leads acceleration by pi by 2. Leads. So it's cosine of phi, and that's minus sine of phi. So if I had to put minus sine of pi by 2 plus phi, something is not correct about it. I don't think that's correct. What do they even mean by lead anyway? Right, I'm just gonna stop. So yeah, I'll see you in the next video. Have a good time.